Screencast covering Chapter 22, Section 1, Part B, Resistance and Ohm's Law. Ohm's law states that the current through a material is directly proportional to the potential difference. Remember, another word for potential difference is voltage, delta V down here. The measure of how strongly an object impedes current produced by a potential difference is called resistance. So here's one form of Ohm's law where resistance is defined by this equation, but I think there's a better way to look at Ohm's law, so I'm going to show it to you here. We can rearrange. You basically swap the I and the R by cross multiplying. And when we get over here, I'd like you to look at Ohm's law more in this way. That says the amount of current that flows in a circuit is directly proportional to how big the voltage is, in other words, how large a battery you have, and inversely proportional to the resistance. The resistance basically comes from resistors, which we'll talk about, or light bulbs, which are basically skinny wires that resist the flow of current and get hot and glow. A circuit element, we've talked about it before in the previous screencast, is a resistor. A resistor is just a device that's designed to have a certain resistance, or in other words, given a certain voltage, it's a resistor that will determine how much current will flow in the circuit. Resistors can be variable. They come in all varieties of flavors. A lot of the sensors that we use in some of our gaming devices and other places have variable resistors. So they're useful. Resistors are useful little devices in circuits, as you'll see. Now, I want to close with just presenting to you two different ways that circuits can be built: the series connection and the parallel connection. Let's look at the parallel connection first. This circuit shows two items, the voltmeter and the resistor, that are in parallel with each other. In other words, they're side by side. The other way to spot a parallel circuit is notice that the current from the battery divides. Some of it goes to the voltmeter and some of it goes to the resistor. Anytime the current has two or more paths in the circuit, it's a parallel connection. In contrast, let's look at this circuit. In this circuit, which this is a series circuit shown here, there is only one path for the current. It can only come out of the battery, pass through the resistor, pass through the amp meter, and return to the battery. Single loops containing elements one after the other are series circuits. We'll work more on these.